Let's say that someone tells you that at a particular school, or maybe in a particular school district, the ratio of students to teachers is 24 to 1. What does that mean when they say that? And a lot of times when you go to get a job in different school districts, one of the things you want to know is what is the student-teacher ratio. Students to teachers. Students to teachers is 24 to 1. So the little colon, we say the word to, T-O. So the numbers always go in the order that the things are in. So if it's students and then teachers, that means 24 is students and 1 is teachers. So that would mean there are 24 students for every 1 teacher. So 24 students for every 1 teacher. So that would also mean if you had 2 teachers, there could be 48 students. So we can start to work with ratios in this sense. So this is the formal definition of a ratio. It's a comparison of 2 quantities. It's usually written as a fraction because we're going to do math with these, right? A divided by B. Or you can write it A colon B. They're both exactly the same thing. They're both perfectly fine to use. Eventually we're going to get to where we use the fractions more, but to start off here initially, A colon B is a good way to start. So ratios can represent part-to-part comparisons, or they can represent part-to-whole comparisons, or even whole-to-part. So I'm going to do an example here just with some dots. So let's say we have these dots. There's 3 red ones. There are, 5 blue ones, and there's 8 total. So you could think of there's part of them are red, part are blue, and then the whole amount is 8. So if I wanted to do a part-to-part comparison, maybe I would want to compare the red part to the blue part. So red to blue would be 3 to 5. Or you could do it blue to red. Blue to red would be 5 to 3. You just put them in the order that you set them. Okay. Or maybe I want to compare part to the whole. Maybe I want to compare the red part to the whole. That would be 3 to 8. Or if I wanted to compare the blue part to the whole, that would be 5 to 8. Or you could do these backwards. You could do the whole to the part. So the total number of dots to the red dots, that would be 8 to 3. Or the total number of dots to the blue dots, that would be 8 to 5. So there's multiple ways that you can set these up, all perfectly reasonable. They're all mathematically correct. It's just what message are you trying to convey and what are you talking about, to determine which one of these you would use. So let's try an example here. Iris has found some dinosaur bones and a fossil footprint. The length of the footprint is 40 centimeters. The length of the thigh bone is 100 centimeters. And the length of the body is 700 centimeters. So what is the ratio of footprint length to thigh bone? So footprint to thigh bone. So the footprint is 40. The thigh bone is 100. So we would say 40 to 100. Or you could write it as 40 divided by 100. But just like fractions, these can be reduced. So if I were to divide everything by maybe 2, if I divide by 2, they're both even, right? I could say 20 to 50. And that would say the same thing. 20 to 50 is the same thing as 40 to 100. But you know what? I could further reduce those. In fact, I could divide by 10, or I could divide by 2, or I could divide by 5. I mean, whatever. I'll say if I divide by 10, it's 2 to 5, or 2/5. Generally, reduced is preferred. But 40 to 100 is the same thing as 2 to 5. This tells you there's 100 compared to 40. Maybe if it was like people, I know this is not people, but it could be 40 to 100 people or 2 to 5 people, right? It just kind of depends on what you're trying to say, and a lot of times we use the reduced form. So a lot of times on commercials, you'll hear on toothpaste commercials, they'll say, 1 in 5 dentists agree that Colgate is blah, 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 whatever. Or 4 in 5 dentists. Well, it doesn't mean there was really only 5. They're giving you a ratio in the problem. So this would be 2 to 5. I think that would probably be the most preferred answer, would be that one for this particular problem. What's the ratio of the footprint to the dinosaur's body? Well, the footprint was 40. The body length is 700. So 40 to 700. Let's divide those by 10. Going to reduce the numbers down. So that would be 4 to 70. And we could probably keep reducing, right? We could divide by 2. And that would be 2 to 35. That would be the reduced form. Or you could say, as a fraction, 2 to 35. Either one of those would be fine. Okay. So to find equivalent ratios, it's kind of like how we found equivalent fractions. To find an equivalent ratio, multiply by any number that you want. It's just if you're going to multiply one number, you have to multiply the other number by the same amount. So just pick a number, whatever you feel like. I don't know, maybe you want to multiply by 10. Okay, if we multiply both of these numbers by 10, we get 20 to 50. And 20 to 50 is saying the same thing as 2 to 5. Multiply by any number you want. Maybe you want to multiply by 4. Okay, if we multiply by 4, 2 times 4 is 8. 5 times 4 is 20. So 8 to 20, that's the exact same thing as 2 to 5, right? So there's an infinite number of answers just depending on what number you would decide to multiply by. There's really no right or wrong way. This is the equivalent of like blowing up the fraction. If you have a ratio that's reduced, we're like blowing it up to make it look bigger.